So let's have a look at the particle settings for a particle playground system. And you'll see in its inspector that you can change the particle count, the amount of particles that is simulated within this particle system. You'll also find this thing called Overflow Offset. And what the Overflow Offset does is that it will offset the birth positions created with a remainder of the points created. So to explain that a bit better, let's say we have this one position created from this transform, and each particle that is a remainder to that 1 point we can offset. So let's try that, just setting 0.1 here on the x-axis. And now we have offset the created birth position here from the transform's origin, each 0.1 step on the x-axis. And we're using the source transform here to for the offset direction. So if we were to rotate this, we get the offset based on the transform's rotation. You can use world space overflow, and you can use source point. And what the source point is, basically it uses the source's normal for a offset direction. And this can be used to, for example, create runway lights. Kind of simple approach. If we were to do this lifetime setting here, which isn't Scramble but rather linear, you'll see that it will create this birth, or it will set the time to distribute linearly over the overflow offset. And let's move on here to source scatter. Source scatter will just scatter the birth positions created. So let's try that out. On the x-axis we have overflow set on the x-axis. Let's just set that to 0. So here we can scatter the source by either rectangular linear will linearly distribute the source scatter with the lifetime sorting taken into account. We can do a spherical source scatter as well, and we can do that linearly. And we can change the scale how this scatter is created. So let's have a look at the emission tab there. You'll find a toggle for if the particles should emit or not. Right now clear on stop was enabled, so the particles just vanished when the effect stopped or the emission stopped. And you can tell the particle system to loop or not, rather make it just a one shot. And if it isn't looping, you can tell the particle system to disable when it's done, or even destroy it. And this won't happen in the editor, just in play mode. So that's the emission. You can change the different sizes of the particles. Let's do this spherically. And you can have a minimum to maximum size, which will randomly distribute how sizes should be once a particle's birth. And you can scale that effect as well. You can change the size by lifetime through a normalized animation curve here. Come on. And you can size the particles through the array of particles. So let's have a look at that. We can do it like this. Oh man. And actually, let's do a overflow offset where you'll see that the starting particles here are smaller than the end particles here. Come on. Let's just drag the slider up a bit. So that's how that works. You can also set the rotation from minimum to maximum value, the initial rotation and the rotation over a lifetime, and if the effect should rotate towards the current direction. For example, this is used by the Valentine preset here, which is kind of just an example of how to rotate particles towards where they're heading. And the lifetime here, you can set that to minimum to maximum value. And of course only do a constant where every particle is has the same kind of lifetime. The lifetime sorting here, we have been touching this value a bit. But, this tells a particle system how the starting time should be created. Scrambled is completely scrambled, where the particle birth positions will be randomly distributed within the specified lifetime. Scramble linear will ensure that no particle will get the same birth position randomly and have the same distance in time. Burst will create this one shot. Linear will make the particles birth linearly within their array of particles. So the particle in the array at 0 position will birth first, and the particle at the last position in the array will birth last. And this can be reversed as well. You have this thing called nearest neighbor, where you can specify the origin of the first particle that should birth, and this is using the source points where the particles are created. You can use a vector 3 here as well to specify where the effects should start. And you can use a transform as well. And if this is set to none, it will use the particle player on systems transform itself. So you can offset the lifetime when it should kind of start, where in its lifetime cycle. And the lifetime emission tells the birth positions created, the birth time created, to be more compact, where if this is set to 1, it will be the full lifetime specified here. But if this is, for instance, set to 0.5 and we have 2 seconds lifetime, it will be 1 second of lifetime created of emission. So this can be used to create this sort of slack one-shot behavior, where if this is set to 0, it will be exactly the same as burst here. And that is why this is grayed out, because it is needed when burst is selected. And then you also have this thing called, let's drag that up to 1, particle mask. And we could do, just to show you, we could do this, have the lifetime sorting to linear. We can overflow offset by 0.1, and let's do a bit less particles actually, because the effect is rather difficult to see otherwise. Let's enable the particle mask. And what this does is that it will just make particles be 0 alpha and not display inside the scene, but it will still be simulated. So when we change how many particles should be have this mask, you see the effect that this is currently linearly distributed over the particles created inside the linear particle array. This can be changed to reversed, where it will start to mask out particles from the end of the particle array. And this could be scrambled as well. And the scramble option is good to use if you, for instance, want to change particle count visually over time. And we could set the mask time here, so the particles will fade in and fade out when this is changed. So that is the particle settings. I hope you got a better understanding of how these settings kind of correlate with each other. And thanks a lot for watching.